let us find this solution. Without performing division, state whether the following rational numbers will have a terminating decimal form or non-terminating decimal form. So what is the first question given here? 13 by 3125. In the same manner, second 11 by 12 and so on like this. So let us find this without performing division. As we have done division in the first bit, but whereas in the second bit, directly by using the denominator condition, that is 2 power n into 5 power n or not. Let us see here. Consider this rational number which is 13 by 3125, in which denominator is 3125. Let's find its prime factors. 5 6 are 30, 5 2s are 10, 5 5s are 25. Next 5 1s are 5, 5 2s are 10, 5 5s are 25. Next 5 2s are 10, 5 5s are 25, 5 5s are 25, 5 1s are 5. So denominator can be expressed in the form of 3125 is equal to how many times of 5? 1 2 3 4 5 times repeated. So it can be written as 5 power 5. As denominator is in the form of 5 power n only, therefore 13 by 3125 is a terminating decimal. We have written this statement based on the condition of denominator, which can be written in the form of only 5 power n. Without actual division, we can state the given rational numbers as either terminating or non-terminating repeating. The given rational number is 11 by 12, in which denominator 12 is equal to, can be written as its a prime factoration, 2 square into 3. 2 square 4, 4 3s are 12, which is not in the form of 2 power n into 5 power n, as 12 is not in the form of 2 power n into 5 power m. Therefore 11 by 12 is a non-terminating, 11 by 12 is a non-terminating repeating decimal. Given rational number is 64 by 455. Is this number cancelled by any common factors? If you check, no. So that let's take this denominator 455 divided by 5 with a 5 factor. If you check, 5 9s are 45, 5 1s are 5. 7 table, we can divide this 91, 7 into 13. Next 13 1s are 13. So 64 by 455 can be written as 64 by 5 into 7 into 13, as 455 written as product of their primes. Now check this 64 is divisible by 5 or 7 or 13. With no number it is cannot be divisible. Therefore it is a non-terminating repeating decimal, as its denominator is not in the form of 2 power n into 5 power m. Therefore 64 by 455 is a non-terminating repeating decimal. Given fraction or rational number is 15 by 1600. So let us consider its denominator and find its prime factors. As we know this method, so 1600 can be written as the product of primes. So let us take 2. How many times it is repeated in this? 1, 2, 3, 4, 5, 6. So 2 power 6 into 5. 1, 2. So 5 power 2. Therefore, the denominator is in the form of only 2 power n into 5 power m. Therefore, 15 by 1600 is a terminating decimal. Given rational number is 29 by 343. So let us find its solution, that whether it is a terminating decimal or non-terminating repeating decimal, in which 343 let us consider and find its prime factors. So it can be divisible by 7 as a divisibility rule of 7. 7 4s are 28. Almost left 6 3, 7 9s are 63. So next 7 7s are, next 7 1s are. So 29 by 343 can be written as, by changing its denominator as a product of primes, that is 7 into 7 into 7, nothing but 7 cube. Here the denominator is not in the form of 2 power n into 5 power m. Hence, what can you conclude here? As it is not in the form of 2 power n into 5 power n, so given rational number 29 by 343 is non-terminating repeating decimal. Here if you observe the given rational number, the denominator is in the form of 2 power n into 5 power m. Therefore 23 by 2 cube into 5 square is a terminating decimal or non-terminating decimal. You can observe as denominator in this format, therefore it is a terminating decimal. Given rational number is 129 by 2 square into 5 power 7 into 7 power 5. Here the denominator is not in the form of 2 power n. Therefore 129 by 2 square into 5 power 7 into 7 power 5 is a non-terminating repeating decimal. Given rational number is 9 by 15, can be written as, by cancelling with a common factor, 3 3s are, 3 5s are, 3 by 5. Here the denominator is in the form of 2 power n into 5 power n. Therefore 9 by 15 is a terminating decimal. If you observe this given rational number 36 by 100, it can be written as 36 by 100, 4 9s are, 4 25s are. So which gives us 9 by 5 square. Here the denominator is in the form of 2 power n into 5 power m. Therefore 36 by 100 can be written as a terminating decimal. Rational number is 77 by 210. Let's convert this 77 by 210 into its simplest form, by cancelling with 7. 7 11s are, 7 3s are, 7 zeros are. So what you get? 11 by 30. Here the denominator 30 can be written as 2 into 3 into 5. 2 3s are 6, 6 5s are 30. Otherwise you can also find the prime factors of 30, that is 2 15s are, next 3 5s are, 5 1s are. So however you are going to get 2 3 5 as their prime factors. So 77 by 210, which is equal to 11 by 30, which is equal to 11 by 2 into 3 into 5. Here the denominator is 2 3 5, which is not in the form of 2 power n into 5 power m. Therefore 77 by 210 is a non-terminating but repeating decimal. Write the following rational numbers in decimal form using theorem 1.4. What does theorem 1.4 indicates? Means convert the denominator in the form of 2 power n into 5 power n. If it is in that format, then it becomes a terminating decimal. So we can write into decimal format. Let us consider the first one, 13 by 25. For first solution, here 13 by 25 can be written as 5 square. As denominator is in the form of 5 square, so it can be multiplied by 5 square into 2 square. At the same time numerator also into 2 square. So that is 13 into 2 square value is 4 by 5 into 2 whole square it can be written. So which is equal to 13 4s are 52 by 5 2s are 10 square, which gives us 52 by 10 square value 100. So as there are number of digits 2 zeros, therefore decimal point comes before 1 and 2 digits. So it can be written as what? 0.52. You can observe this 13 by 25 whose decimal expansion is 0.52. Let us consider second problem, 15 by 16. So it can be written as 15 by 16 whose decimal expansion, if you observe, let's find its prime factors. 2 8s are, 2 4s are, 2 2s are, 2 1s are. So 16 can be expressed as 2 power 1 2 3 4, 2 power 4. As we need to convert into 2 power n into 2 power m format, so it is to be multiplied with 5 power 4 by 5 power 4. So which gives us 5 power 4 value 5 into 5 into 5 into 5 by 2 into 5 whole power 4. So which gives us 5 into 5 5s are 25, 5 5s are 25, 25 25 625 by 10 power 4. Now multiply with 15. What you are going to check in the numerators? Let us see that 15 5s are 75, so 7 to be carried, 5 here, 15 2s are 30 plus 7, 37, 3 should be carried to the next place, 15 6 are 90 plus 3, it is 93 by 10 power 4 is gives us in the next step as its decimal expansion 0 point, count the number of zeros in this 1 2 3 4. So After the decimal point there exists 4 digits, that is 0.9375. Here given rational number is in the form of 23 by 2 cube into 5 square. Let's convert the denominator as a multiple of 10. So if you observe the powers of 2, 2 power 3, here 5 power 2. So now we should convert this into common factors or common exponents. In order to that, you should multiply given expression with 5, numerator and denominator. So 25 into 5, 23 into 5, 5 3s are 15, 5 2s are 10 plus 1, 11, 115 by 2 power 3 into 5 power 3. That is 115 by 2 into 5 whole cube, which gives us 115 by 10 cube, which is equal to 115 by 1000. So now as the fraction consists 3 zeros in its denominator, so we can take a decimal point as 0.115, which is the required decimal expansion. Expression is 7218 by 3 square into 5 square. First convert into simplest form. 7218 by 3 square can be written as 9 into 5 square, which is equal to, is it able to cancel or not? Let us check with 9. 9 ones are 9. How many times possible? Let us check here. 9 8s are 72, 9 0 0, 9 2s are 18, that is 802 by 5 square. So here in the denominator only 5 square is there, so that multiply numerator and denominator with 2 square with equal powers of 2 and 5. So now what you get? Let us check here. 802 into 2 square is 4. Denominator can be expressed as 5 into 2 whole power 2. When powers are same, bases can be multiplied. So now 802 into 4. So with 4 2s are 8, 4 0 0, 4 8s are 32 by 10 square. Here 3208 by 10 square is nothing but 100. So what is its decimal expansion then? As denominator consists only 2 zeros in its decimal, in its denominator, so decimal form consists 32.08. Question 143 by 100. Given rational number is 143 by 110. So it can be written as 143 by 110, 143 by its factors 11 into 10. In the same way, 11 ones are 11 ones are 11, 11 threes are 33. So 33 by 10, 13 by 10. If you cancel this, you will get as 1.3, as the denominator consists only 1 0. So the answer you will get as 1.3 in its decimal expansion. So let us see the fourth bit from the exercise 1.3. What is the question? Let us observe that. Express the following decimals. This type of decimals are given in the form of what? P by Q. So convert this into fractional form, and what the prime factors of Q when you written in the form of P by Q, consider the or find the prime factors of Q, and what you observe or what you notice from that you need to mention. So here the given question is 43.123. So it given number which is equal to 43.123. Now express this number in what format? In P by Q format or P by Q form. What do you get? 43, 1, 2, 3, nothing but 43,123 by, if you remove the decimal point, how many digits are there after the decimal point? 3. So you can write 3 zeros. So what does it become? 1000. Now factorize the denominator. So when you factorize the denominator, what do you get? 1000 can be written as 10 cube. So 10 can be written as 2 into 5 whole cube. So which can be split, that is 2 cube into 5 cube. Right? When you factorize, so very simple, 1000 can be written as what? 10 cube. 10 cube can be written as what? What are the factors of 10? 2 into 5. So 1000 is multiple of 10. So 10 can be written as multiple of 2 and 5. So this power can be split to bases 2 and 5. Then it becomes what? 2 power 3 into 5 power 3. So the denominator is in the form of here 43,123 by 1000, which can be written as 43,123 by 2 power 3 into 5 power 3. The denominator is in the form of 2 power n into 5 power m only, so that it is a terminating decimal. Right? When it is a terminating decimal, then the given number is 43.123 is a rational or irrational numbers. All the terminating decimals comes under rational numbers. Yeah, given decimal is, if you observe clearly, 0.20, 11, 200, 11, 2000, 1 and so on. Is this having any certain pattern or any pattern is repeating in this in a proper way? No. See that 20 after again different number got. 211 after 2011 after again 2011 it did not get. So there is no particular pattern, therefore it is neither repeating. And is this terminating after certain number of digits means? No. It is given as so on. So that as given number or decimal is clearly neither terminates, neither terminating nor repeating, so it cannot be expressed in the form of P by Q. So when if it is possible only we can express in the form of P by Q. As the given number is neither terminating nor repeating, so we cannot express in the form of P by Q here. The given question is 43.12 bar for only 2 decimals, that is 1 and 2. So this given number or decimal to be converted into the form of P by Q. So whenever the bar is given these type of numbers, how to convert? So let us see, that is most important case. So you need to practice these type of problems in the keeping view of exams. Let us consider the given number 43.12 bar. that is, let x is equal to 43.12 bar, which is equal to 43.12. If you remove the bar or vinculum, it will become what? 1 2 1 2 1 2 and so on. That means the bar indicates the digits which are recurring, the digits which are repeating. If you write in the form of repetition, no need of keeping bar. If you don't want to write in the form of repetition, you need to mention another bar. So x is equal to this. Now how many digits are repeating here? Number of digits repeating is how many? Number of digits recurring or repeating is equal to what? 2. Therefore, with what number we should multiply? If it is number of digits recurring 2 means you should multiply both sides with 10 power 2. That is what? 100. How many digits are repeating? With that power we should consider multiples of 10. So which is equal to what? 100. Therefore, multiply by 100 on both sides. What is this equation becomes then? 100x is equal to, when you multiply this, decimal point moves towards right side 2 digits, that is 4312.1212 and so on. Whatever the digits repetition is given, that will be remains same here. Now this one x value to be subtracted from here. What is the value of x here? 43.1212 and so on. Let us subtract. For sake of understanding, we can also treat this as what? Equation number 1. 1 is subtracting from where? 2. Okay. So 100 minus x is 99x, which is equal to, so this so on removes, 2 and 2 gets cancelled, 1 and 1 gets cancelled, 1 2 1 2, that nothing but 1 2 1 2 gets cancelled, 1 2 1 2. Whatever the recurring digits are there, it will be cancelled. Then here decimal points also gets cancelled. Then 2 minus 3, as it is not possible, borrow, it becomes 12. 12 minus 3 is 9. Then what left over here? 0. That means when you borrow, it becomes 10. 10 minus 4, 6. Here as you lent 1 to this, here left as 2 only. The 2 remains the same and 4. So it becomes what? 4269. 69. Then x can be written as x is equal to into 99. If you transfer this side, it becomes 4269 by 99. So with which common factor it is cancelled, we can check it. So whether denominator is divisible by 3 according to the rule of 3. What about the numerator? Check the sum of the digits. It is divisible by 3. This is divisible by 3. 4 plus 2, 6. It is also divisible by 3. So we can cancel it with 3. 3 3s are, 3 3s are, 3 1s are, 3 4s are, 3 2s are, 3 3s are. So it becomes 1423 by 33. Again, is it divisible by 3? Check it. Sum of the digits: 1 plus 4, 5. 5 plus 2, 7. 7 plus 3, 10 by 30. So it cannot be divisible by 3. So it is also cannot be divisible by, so both cannot be divisible by 3. Hence 3 is, as 3 is not common factor, you can remain the same. So 43.12, which is equal to 1423 by 33. Let's check its denominator by writing its prime factors. 33 can be written as 11 into 3. as denominator is not in the form of 2 power n into 5 power m, therefore it is neither terminates or not a terminating decimal, but repeating. Therefore 43.12 bar is a rational number. So these type of problems are most important keeping view of examinations, and you need to concentrate what kind of logic we are going to apply on the given decimal. When it is repeating, how many digits are repeating, we need to carefully observe. So with that we need to multiply, then first equation you will get a second equation, by their difference we will get the required phi by q form of number. Yeah children, this is also very easy one, 0.63 bar as we have done earlier. Let x is equal to 0.63 bar, which is equal to what? 0.63, 63, 63 and so on. What are the digits repeating here? 63, 63, 63 and so on. Let it be equation number 1. Now how many digits are repeating in this case? 2 digits are repeating, so that we should multiply equation 1 by 100 on both sides. As number of digits repeating 2, so with 10 square we should multiply. 10 square is nothing but what? 100 on both sides. Then the equation becomes 100 times of x is equal to, when you multiply with 100, decimal point moves 2 digits towards right side. Then what does it become? 63.63, 63, 63 and so on. Let it be equation number 2. Now subtract equation 1 from 2. So let us write equation 1 here. X is equal to 0.63, 63, 63 and so on. So we are going, when you are subtracting, what is its coefficient? 1. So 100 times of x minus 1 time of x. There are 100x minus 1x. It gives us what? 99 times of x. So which is equal to 63, 63 gets cancelled. 63, 63 gets cancelled. Here 63, 63 gets cancelled, which are repeating. As repeating decimals gets cancelled, what left over before the decimals? 63 minus 0, nothing but 63. Now let us find the value of x, that is x is equal to 63 by 99. So when you cancel with 3, check it as 3 is a common factor. So 3 2s are, we can write as what? 3 2s are, 3 1s are, 3 3s are, 3 3s are. So next 21 by 33 also we can cancel with the 3 once again. 3 7s are, 3 11s are. So what is the p by q form of the number we got it here? 7 by 11. So when you observe its denominator, we cannot split into other factors as 11 is a prime. So this denominator is not in the form of, here the denominator is not in the form of 2 power n into 5 power m. So what can you conclude? As it is not in the format this one, therefore 0.63 bar is not a terminating decimal. not a terminating decimal. So 0.63 bar, as it is a bar, as these digits are repeating, it is not terminating but recurring or repeating, both same. 0.63 bar is a rational number.